Lungs are composed entirely of soft sponge-like tissue and lack any skeletal muscle. Because they cannot physically move on their own, the common idea that they pull air into your body is a biological impossibility. This is the real mechanism. These organs are passive participants in respiration. Without a way to contract or expand their own volume, lungs rely entirely on external forces to facilitate the movement of air. That force is generated by the diaphragm. This dome-shaped muscle sits just below the lungs, responding to constant involuntary signals sent from the respiratory centers in your brainstem. The process functions through the automatic manipulation of atmospheric physics, leaving the lungs themselves entirely passive as the chest cavity changes shape around them. Governed by Boyle's law, a container's volume and internal pressure are inversely related. If the container grows, pressure drops. Your thoracic cavity follows this exact principle. Using the diaphragm as a movable floor, your body instantly increases its internal chest volume. This expansion creates an internal void. Instead of your body sucking air, the higher pressure atmosphere outside actively forces air into your chest to equalize the difference. Inspiration begins when the brainstem triggers the diaphragm to contract. It flattens downward, pushing against the abdominal cavity to create more vertical space. At the same moment, your external intercostal muscles lift the ribcage. This combined effort expands the chest in every direction at once. As the volume reaches its peak, the pressure inside your lungs falls below the pressure of the air around you, creating a powerful internal vacuum. Atmospheric air rushes down the trachea and through the branching bronchioles, surging toward the deepest parts of the lungs to fill that low-pressure space. This massive coordinated effort builds a physical delivery pipeline, moving air from the scale of the room to the scale of the cell. The air travels to the terminal point of the respiratory system, 480 million microscopic air sacs called alveoli. To keep these delicate bubbles from collapsing under their own surface tension, specialized type II cells secrete surfactant, a fatty substance that maintains the structural integrity of the sac. The walls of these sacs are type I squamous cells, creating a 0.2 micrometer blood-air barrier. Oxygen molecules cross this membrane to bind with hemoglobin in red blood cells, while carbon dioxide unloads into the alveoli. This rapid molecular exchange is the singular chemical goal that the entire mechanical respiratory system is designed to achieve. Expiration starts when the diaphragm relaxing, springing back upward into its natural dome-shaped resting position, reversing the entire mechanical process. As the rib cage lowers and the diaphragm rises, the volume of the chest cavity decreases sharply, causing internal pressure to rise above the atmospheric level. This high-pressure state physically squeezes the carbon dioxide-rich air out of the lungs, resetting the system for the next cycle. While lungs handle external respiration, the process only succeeds if the oxygen reaches its final destination, the cellular tissues where internal respiration fuels your metabolism. This chart displays the baseline volumes for a healthy respiratory system, including total lung capacity and vital capacity. Over time, factors like aging or illness can cause the lungs to lose their natural elasticity, significantly reducing these measurable capacities. To protect the delicate alveoli, the body employs cilia and mucus. These defenses act like a conveyor belt, sweeping out dust and invading particles before they can damage the gas exchange surface. Maintaining the physical flexibility and cleanliness of this machinery is the only way to ensure that oxygen reaches your cells for as long as you live. In this light, breathing functions as a total biological submission to physics. Every breath is the result of your body precisely shifting its internal geometry. You do not pull air in, you simply create the space, allowing the weight of the Earth's atmosphere to push life into your chest.